So for this next IQE, my question reads, in chemistry lab, you're running a gravity filter system. The filter has a piece of paper with a thickness of 6 millimeters and a diameter of 3 centimeters. This paper has a flow area of equal to 5% of the total area, and it takes the filter 3 minutes to drain 45 milliliters of fluid. And the fluid is similar to water. What will the particle size be? So, as you can see, we have our nodes. We have our volume of water and our time to drain it, the diameter of the filter and the length of it, and we're saying P1 will be equal to atmosphere, and then since it's a vacuum filter, we're going to assume P2 is 0. Then we're finding our particle diameter. You can see our assumptions: incompressible, change in H is negligible for this, and we're saying P2 is 0. And then we have our viscosity of water and our gravity. Next, we're going to write out the extended Bernoulli equation. We're going to say that change in height is negligible, and we're also going to say the kinetic terms will also be negligible as the water is flowing at such a small velocity. So we're just left with the friction factors equal to P1 over rho, and you can see we found the friction factor. After finding the friction factor, we can use one of the equations for it. You see there, we know this is laminar flow, so the turbulent flow will be very much negligible in this case. And using that laminar term, we can find the particle diameter to be around 0.15 millimeters. Then the second conceptual question says, what would an increase in the pore diameter cause? Would you preferably want a small pore size or a large pore size? And then I said an increase in pore diameter, holding everything else constant, will cause the rate at which fluid is filtered to increase. Depending on the end goal, this could be good or bad, but I said generally speaking, we're going to want only liquid to leave the filter, and this increase in pore diameter, as long with the associated increase in flow rate, may cause some unwanted solid to be filtered out when our end goal is just for that fluid to be taken out.